Stripping down science. The Naked Scientists.
Hello, and welcome to this week's Naked Scientists with me, Chris Smith, with Kat Arney.
Hello.
And with Dave Ansell.
Hi.
This week, the inside information on the Loch Ness Monster. Is he real? Is it fact? Is it fiction? Also, how scientists have come up with a pill to reverse the effects of ageing and prolong your life by some 20%. And the good news is that the chemical they're working on is also in red wine. Scientists have also come up with a possible male contraceptive pill, which we'll be talking about later, and the flu season's looming. Researchers have found that your likelihood of succumbing could be down to your genes. What's all that about? Find out later.
Remember, it's the 5th of November, and in this week's Kitchen Science, we're going to be showing you some of the science of fireworks, and how one scientist has blasted his way into the record books.
We actually set up 56,459 rockets in frames, and tried to ignite them all within a very short period of time. At the end of the day, we actually only had 4 left in the frame.
That was all in the space of less than 30 seconds. So we'll be hearing from the Master Blaster, Roy Lowry himself, later on in the show. Don't forget, this week is also our Naked Scientists question and answer show. We're devoting pretty much the entire show to tackling your questions. So if you've ever wondered why woodpeckers don't get headaches or brain damage from banging their heads against trees, why are banana skins slippery, and in my case today, why, if you're running late, do you always get stuck in traffic, you can call in, ask us anything you like. It's 08459 25 2000.
But first of all, have a listen to this. This is our teaser question this week. If you think you know the answer, you could be walking away with our planetarium or some copies of my book, Naked Science. How many nerve cells are there in the average human brain?
The Naked Scientists podcast, powered by UK Fast, the UK's best hosting provider, on the web at ukfast.net.
Now, the legend of the Loch Ness Monster is an ancient one, apparently, although it was renewed and become really popular since 1933.
Do you believe it, Dave?
I am definitely reserving judgment very strongly here, Chris. Apparently a couple reported an enormous animal rolling and plunging on the surface of Loch Ness while they were driving around in their car.
It could have been me in my swimsuit.
Well, you're the Loch Ness Monster.
Yeah, an enormous creature rolling and plunging.
Anyway, photos and accounts said that it has a very long neck and a big body, and the neck kind of comes up like a swan looking out of the water.
Sounds a bit more like Chris, actually. Anyway, carry on.
I'm sorry. Anyway, various people have suggested this could be a plesiosaur. This is an aquatic reptile with a huge big body, flippers, and an incredibly long neck with big sharp teeth on the mouth. It's supposed to have lived between 220 and 65 million years ago in shallow waters. Now, Leslie Noe has been studying these, particularly their necks, which were absolutely enormous, so as long as their body and the tail combined, so some of them were up to 10 metres long. Now, he's been looking at how the bones in the neck articulate, and he's discovered that when the neck was pointing down, it was really flexible. But when it was coming upwards, it wasn't flexible at all, and it wouldn't actually have bent up like a swan at all.
So does that fit with what these animals actually did?
Well, the way they think they lived was they were swimming around in a kind of shallow sea on the surface, and then there'd be like fish and ammonites and all sorts of nice tasty morsels swimming around in the water underneath. They'd use this big long neck and grab them and eat them really quickly. And so, unfortunately, for all those Nessie fans, they're going to have to think of another animal for the Loch Ness Monster to be.
So all those sort of the traditional pictures where it looks like there's almost a periscope sticking up, that physically couldn't have happened if it was a plesiosaur?
Unfortunately not, no.
Oh, disappointed. Anyway, if you're old, overweight and male, then I have some good news for you. You could be given a new lease of life by the chemicals found in grapes, wine and nuts. But at the moment, only if you're a mouse. Researchers led by a team in the US have found that old male mice who had been used to chowing down on a very high-calorie diet actually enjoyed better health and they lived longer if their diet was supplemented with this chemical called resveratrol. Now, this is a plant chemical that's found in red wine, in grapes, nuts and that kind of thing. And they think that it helps to stimulate parts of the cells that are responsible for metabolism and help the cells to stop ageing. So over the past few years, researchers have found that resveratrol can help yeast, worms, fruit flies and fish to live longer. But until now, they haven't actually shown it to work in a mammal. So now it works in mice. And because we're actually quite similar to mice, some of us more than others, it might be that resveratrol could actually help humans to live longer. But at the moment, we don't know how much you'd need or this kind of thing.
I think the really encouraging aspect of this is that, if it works in all these different animal species, it's really likely to work in humans, isn't it?
Exactly. All the same molecules, these proteins called SIRT that are in our cells that are responsible for ageing and metabolism, they're in all animals from yeast upwards. Well, yeast not an animal, but in all organisms. So it is very likely that we could use this chemical from red wine to boost our life length.
It's really encouraging it's also in red wine because I suspect there's lots of wine growers who are rubbing their hands together, but also lots of wine drinkers like me.
Exactly, the odd glass of wine.
The guy who discovered that, actually, David Sinclair, who's at Harvard Medical School, has, with his colleagues in Massachusetts, formed a company. It's called Sertraris Pharmaceuticals, and they actually have an agent called SRT501, which is in clinical trials. And what they're doing with that agent is giving it to people who have diabetes to see if they can improve their sort of fat profile, in other words, how much fat is going around the bloodstream, and therefore their clinical health.
Does this reduce the excuse you have to drink red wine, though?
Yeah. Eat nuts and red wine, I reckon.
Anyway, I've been looking at a related thing. Professor Sheldon H. Jacobson in the University of Illinois has calculated how much extra fuel cars in America use just because people have gained weight over the last 30 years. Apparently, since 1960, people on average have gained 11 kilos of weight. And Sheldon has calculated that because cars, if you put more weight in them, it takes more fuel, they've got to go up hills, it takes more energy to accelerate and decelerate them, that this extra fuel used is about 750 million gallons, or 3.7 billion litres.
And that's just the US?
That's just the US. Although it's quite small compared to other effects, it is quite interesting to notice that.
Well, it's a significant amount, isn't it? Because that's just ignoring the health costs. Because of course, being a lot fatter does carry a health risk, and it's not just America who are overweight. I mean, the whole of the Western world is now carrying a lot more around the middle than they should be. So it's not just the car that's paying the price; it's your own heart and health, isn't it?
And this wasn't even taking into account the fact that overweight people probably don't walk as far, and so they have to make more car journeys as well.
Bad news for the environment. Now, what about the pill? Because this is something which for many, many years has been seen as the preserve of women to control contraception and that kind of thing. Well, there's a group of scientists in America led by a guy called Chunyang Cheng, who's at the Center for Biomedical Research in New York. And what he's come up with is a drug which could stop temporarily the production of sperm in men to make men temporarily infertile. So it's the male equivalent of the pill. Now, it builds on a piece of research they did previously, which worked on a chemical called Adudin. And they've called it Adudin because it has a hopelessly complicated long chemical name, so they've shortened it to Adudin. Now, when you give this chemical, what it does is interfere with the way sperm are produced. Now, sperm are produced from stem cells in the testes, and they're nourished and nurtured by a special cell called a Sertoli cell that they snuggle up to and form a very close attachment with during the time that they're maturing. Now, what this Adudin chemical does is to get between the sperm and the Sertoli cell and detach the two. And if you detach the sperm from its Sertoli cell, it can't mature, and therefore you lose your fertility for as long as that detachment occurs. The only problem was when they gave this chemical to some experimental animals, it caused liver and muscle damage because it's quite a nasty drug, certainly at the doses they had to give it. But they found a way around this problem because they've coupled the drug to a hormone which is naturally found in the body called FSH, or follicle-stimulating hormone. And the way follicle-stimulating hormone works is it goes from the brain down to the testes and tells them you need to make more sperm. So by linking this Adudin chemical to the FSH chemical, it gets targeted just to the testes where it's needed. And when you do this in mice, you can give them very, very small doses, and it temporarily, for about 4 weeks or so, stops them producing any sperm. And after 8 weeks, it's all washed out of the body, and sperm is back to normal. So that's encouraging.
I still don't know if I'd trust any man who said, "It's all right, darling, I'm on the pill." That's something that science can't help with, unfortunately. Anyway, it's the time of year for sniffles and sneezes, and many of us are telling the boss that we're laid up with the flu. In fact, you've probably just got a very bad cold, because flu can kill. It's such a serious infection. It usually targets the very young and the very old. But every so often, we get a huge epidemic of flu, such as the one in 1918, and it kills millions of people of all ages around the world. Now, we have the doom mongers predicting the next flu epidemic in the form of bird flu, or even just a normal mutated flu. But what we don't know is, why does flu kill some people and it doesn't kill other people? Now, researchers at Southern Illinois University School of Medicine in the States are trying to find out by studying genes that are involved in making the immune system respond to attacks by flu. And what they've been doing is studying two genetically different strains of mice. So they're mice that are mostly very similar, but they have subtle genetic differences between them. And they find that these mice respond differently when they get flu. So some of them mount a massive immune response in their lungs and are much more likely to die from the infection, whereas other mice seem to fight it off quite well and don't die. And because there's this difference in the strains, then you know that it must be down to the genes, the genetic differences between the two sets of mice.
And we think this is happening in humans too, do we?
It's highly likely that it is, because we're such a genetically diverse population. So what they're trying to do now is track down what it is in these mice that makes them either succumb or be resistant to dying by flu.
Does it depend on the strain of flu, and different strains affect different mice differently, or have they only tested a couple?
Well, this research has just been done with one strain of flu, so presumably the real situation in humans would be much more complicated, but at least we know that it's down to the genes.
The Naked Scientists, supported by the Wellcome Trust.
Well, it's time to head across the pond and hear from Bob and Chelsea for the science update. But before we do, we've been contacted by a listener who's also in America, in New Jersey, and it's from Spartak. And he says, thanks very much for your fun and informative podcast. And he listens to us on his 2-hour commute from New Jersey to New York City, and he actually looks forward to it because of the Naked Scientists. Crazy man. Anyway, this is time to go now to hear what Bob and Chelsea have got for us in their science update. This week they're going to be finding out about new research into the Dead Sea Scrolls and why shoelaces were once worth their weight in gold.
This week for the Naked Scientists, we'll tell you why indigenous Cubans traded their gold for the shoelace tags of early European explorers. But first, Chelsea is going to update us on the science of one of the most famous archaeological finds of all time, the Dead Sea Scrolls.
The Dead Sea Scrolls have been called the greatest jigsaw puzzle in human history. That's because the 2,000-year-old Jewish religious manuscripts were discovered in about 40,000 pieces. For years, scholars have tried to match up the bits of animal skin parchment using their shapes, colors, and written content. But now scientists are getting help from the skin's DNA. Adolfo Reutmann, the Dead Sea Scroll curator at the Israel Museum in Jerusalem, explains how it works.
Once the DNA is recovered, in a way is to have in hands the ID of the parchment. And then, if we can recover from different pieces the ID, then we can compare if one fragment fits the other on the basis on the ID.
Reutmann says DNA has also told scholars which kinds of animal skins were used for parchment. That's important because some animals were considered pure and were used for holy manuscripts, while others were considered profane and wouldn't have been used in holy places. Also, he says they're trying to match the manuscripts to some actual bones that they've found, which could solve the long-standing mystery of where exactly the scrolls were made.
Thanks, Chelsea. At a 500-year-old Cuban burial ground, local archaeologists and their colleagues from University College London have found opulent jewelry made from surprisingly humble materials. They were brass shoelace tags called aglets, manufactured in Europe and traded to the indigenous Cuban people for gold. That may sound like a bum deal, but field director Diego Cooper explains that back then, gold in Cuba was abundant and not very valuable. Instead, the social elite decked themselves in a copper-based alloy called guanine.
And when the Europeans turned up, the brass objects which they brought with them were quite similar to guanine and also represented a high social status.
Caught off guard, the first Europeans traded away whatever brass trinkets they happened to have on hand, or in this case, on foot.
Thanks, Bob. Next week we'll talk about the Sun-Earth connection and its effect on some GPS receivers, as well as the rise and fall of species. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society. Back to you, Naked Scientists.
Thanks to Bob and Chelsea. And if you can't wait till next week for your injection from the Science Update team, you can go to their website, which is www.scienceupdate.com.
Got an email here, or a question here, who's David's in Chelmsford. He says, do plants and trees communicate? What do you guys think?
I think they can in some ways. They certainly share pollen between themselves, which I guess might be a form of communication.
I suppose so. It's more cunning than that, because there is a sort of chemical communication that goes on, from what I can remember. I think there was a piece of research done fairly recently where they looked at things like plants having leaves pulled off, and they found that they scream chemicals to signal damage to other plants. There's a number of chemicals that are produced. One of them is ethylene. ethene, carbon with two double bonds to another carbon, a double bond to another carbon atom and some hydrogens coming off the side, and that is actually a signal which says to the plant, I'm actually being damaged, grow some more, or it also makes fruit ripen, because tomatoes can be ripened up by squeezing some ethylene on them. So I suppose that's another signal saying, hey, I'm being damaged, get your plants fruits ripe quickly so that they get eaten and then the plant can reproduce.
And intriguingly, bananas produce loads and loads and loads of ethylene. So if you've got fruit that refuses to ripen, stick bananas in your fruit bowl.
I think you also get all sorts of interesting communication between plants and fungi in the soil.
That's right.
Because the fungi can bring all sorts of useful things to the plants, and the plants give the fungi food.
There's the relationship, it's a mycorrhizal relationship is what it's called, isn't it? And you have a fungus which forms a dense network through the soil and up close to plant roots, and it secretes goodies that it can make in return for goodies the plant can make, and so both benefit because the plants get this massive sort of root system which is actually a fungus. I think people used to think there were two forms of thistle plant and two species, a dwarf thistle and a tall thistle, and it turned out that there's no difference between the two. It was actually what type of fungus they had growing around their roots, and it was called a Hartignet A and a Hartignet B. Well, I remember. Another interesting plant signalling hormone is traumatic acid. When you damage a plant, it signals it's been damaged and it produces this stuff called traumatic acid, but I think that's a sort of internal signal.
We've got a question here from Kai in China, and his question is, how many different things can we memorise? Different people have got different memories, but what's the most that anyone could memorise?
Well, in terms of the most that people can memorise, there are sort of super memorisers. And there was a programme about this chap on the telly recently who could just memorise all manner of things. But another part of the question is, why are we different? Why can some people remember loads and loads and loads, and some people can't remember anything at all? And the difference is, again, down to your genes, and it's how your brain works. Because, as you can answer our teaser, we have many neurons in our brains, and your memory works by making contacts between these neurons and reinforcing them through something called long-term potentiation. So when you're making a memory, when something happens to you, you get this kind of reinforced signals going on in certain parts of your brain, part of the brain called the hippocampus, a part of the brain called the amygdala. But what we don't know is how memory actually works and why some people can remember things like languages and other people can't. So we don't know how it works, but we do know that actually if you learn different languages, and particularly from a very young age, for example, if you're brought up bilingual, it actually builds more grey matter in your brain.
Study, was it Andrea McKelly from University College London, scanned people who are bilingual, didn't she?
Yeah,
and they've got
exactly.
more language cortex, a thicker rind around the outside of the brain wherever the cortex is that processes language function.
The left front bit of your brain, they have thicker, more grey matter, but works best if you're brought up bilingual from a young age.
James is in Castronsea. Hello, James. Welcome to The Naked Scientists. How do you do? Let's go to Mike, who's in Hawkwell. Hi, Mike.
Hello,
how are you?
I'm very well, thank you. And yourself?
Very well, thank you. What's your question?
I understand that there's background microwave radiation that's an indication of the universe starting as a Big Bang.
That's right.
I've looked on sites on the internet and they're a bit difficult for me to understand.
Yeah.
So I need to know in fairly simple terms, when was it produced, why was it produced, and why is it hanging around?
Okay, this is basically the light which was given off when the universe became transparent. When it was very, very hot, it was all a plasma, when all the electrons and the nuclei were flying around, and that was just giving off light in all directions, and it was opaque. But once the electrons started becoming atoms, it went transparent, and that gave off lots and lots of light because it released lots of energy. Now, that started off being sort of X-rays and ultraviolet light, but over the billions of years, it's about 15 billion years, I can't remember the exact age of the universe at the moment, it's definitely old. Because the universe has expanded, that light has got stretched. And the wavelength has got longer and longer and longer, to the point at which it's, instead of being about less than a trillionth of a metre long, it's up to a few centimetres. And that's the microwave which you see, which is coming from all directions, because it was made in the whole of the universe at once.
I think one good analogy that I heard to sort of explain this, Mike, was if you can imagine an ant crawling along an elastic band, and the elastic band, when you start off, is obviously quite short, but then you can suddenly stretch it. So the wavelength, the distance the ant's got to walk, has now become a lot longer. And that's sort of the universe stretching, and it's taking the light that was with it. So you get this stretching effect, which makes the light have a very long wavelength compared to when it first started.
So it'll eventually become on radio waves?
Well, microwaves are sort of in the same domain. They're non-ionising radiation. So, yes, that's right. They've come up to that part of the electromagnetic spectrum.
But it will take many billions of years to get to radio waves from now.
I won't hold my breath there.
Do you want to go at the quiz, Mike?
Yeah, I'll have a go.
The force needed to pull out a 2-inch or 5-centimetre nail from a piece of wood is the equivalent of lifting 26 kilos. That's about half a person. Do you think that's science fact or science fiction?
Sounds about right. We'll go for fact.
You're right. The force required to withdraw a 5-centimetre nail from a piece of hardwood is the same as lifting 26 kilos. That's why it's so difficult to pull out a nail if you just grab it with the pliers, and why it's much better if you use a claw hammer, because then you can get a lever and be much more efficient.
The thickness of the soap film on a bubble, so when you look at a bubble you've blown, is about 0.5 millimetre. Fact or fiction?
Fiction, I think it's less.
Yeah, well done. Isaac Newton himself first discovered that you get lots of colours in rainbows due to interference between the two sides, and it's actually about a 10,000th of a millimetre thick.
Brilliant. So does that answer all your questions and everything?
Yeah, thank you very much.
Excellent.
Do you want a quick go at the quiz?
We've done the quiz.
Oh, sorry. I thought I meant the teaser, Kat. Sorry, Mike.
It's all
hang on a minute. What I was trying to say, Mike, is do you want to have a go at the teaser? Have you had a go at our teaser?
No, I don't think so.
Okie dokie. Well, have a think about this one. We want to know what we're after this evening is how many cells there are in the average human brain. If you think you know the answer, here's Kat with the number.
You can ring us on 08459 25 2000. And we've also had some answers in already. So Betty in Northampton says there's 10,000 million nerve cells. So that's pretty close. None, says John in Peterborough.
Depends where you live, I think.
It may be usual for Peterborough. And we've had some listeners from the Costa del Sol. Hello. They phoned in. We have Eddie Cooper who says 100 billion and more than 10 billion, according to Chrissy in the Costa del Sol. So close.
Keep your calls coming in if you think you know how many cells there are in the human brain. It's Chris, Kat and Dave, and this is The Naked Scientist. Joining us from the Costa del Sol is Jack Nesbaum. Hi, Jack.
Hello.
Welcome to The Naked Scientist. What do you want to talk about?
Very, very interesting. You're touching on some real good stuff here.
Oh, well, that's very kind of you to say so. What do you want to touch on?
Okay, listen, I have a question when you dealt with memory just before. Okay, my question here is, a number of things happen to most people, or at least with myself. Memory is triggered by music, by smell of food, different places, and songs, music, very interesting stuff. How does that happen?
Well, the thing that's going on here is, as Kat mentioned earlier, the brain is full of a dense nest of connections from one nerve cell to the other. And if you take smell as an example, because you've already mentioned that one, and that's a good example, when you have a smell coming into the nose, first of all, smell molecules, odorants as they're known, dock with tiny receptors on the surface of nerve cells, and they trigger nerve cells at the top of your nose. And they then pass through fine nerve fibres into a structure called the olfactory tract, which then runs underneath the brain and then goes directly into the surface of the brain. And it links up with parts of the brain that are very close to where memory is encoded in our brains. And so what we think is going on, because smell is a very primitive sense, it's connected to that part of the brain which is concerned with our kind of emotions, our animalistic behaviour, our sex drive, our general arousal, and also where memories are laid down. And for that reason, what scientists think is going on is that when you're presented with a smell, it triggers or unleashes all these other sensations, probably because there are multiple ways into a cell to find, or multiple routes to find the same information. And so if you hear a combination of sounds and smells and events, then it can unleash this cascade of sort of cell connections, which triggers memories.
It's also very interesting the way that memories are stored in our brains, because there have been some ideas that, you almost store it like a film clip. Something happens to you, you store it like a film clip. But new research is showing that actually your memory is probably more like a jigsaw puzzle or a collage, and you've got all sorts of bits all over the place. So it's quite easy to trigger and build memories from all these different things. So that's how they think it works.
Let's go to James, who's in Caister. Hi, James.
Good evening.
How are you?
I'm fine, thank you.
Welcome to The Naked Scientist.
I must apologise if there's background noise here. My neighbours are having a firework display.
Oh, right. Well, that's very topical, isn't it? It being the 5th of November. We're going to be talking in a minute to the guy who's blasting his way into the record books for letting off more fireworks than anybody else. He's called Roy Lowry. He's from the University of Plymouth, and he would love any questions on fireworks if you'd like to send them in to us. Phone number 08459 25 2000. Sorry to interrupt, James. What would you like to talk about?
When I began to get towards retirement age, I started to get hairs growing out of my nose and my ears.
Mm-hmm.
And it seems to happen with most men at this age.
Mm-hmm.
Please tell me, why do I need hairs growing out of my nose and ears when I get to retirement age?
Well, unfortunately, as a consequence of us being blokes, we tend to get hairier as we get older. It seems that testosterone, which is the hormone that makes us uniquely male, and it's responsible for us having a short attention span, for us having sort of our brains in other parts of our body sometimes. It also makes hair grow, and in some parts of the body, but not in others. It makes your skin greasier, and it makes hair fall out in other places. So the hair follicles on the top of your head are quite sensitive to testosterone and the way it gets metabolised, and that makes them fall out. But in other parts of the body, it encourages hair growth. And over time, there's a sort of exposure effect. The longer you're exposed to it, the more likely it is for cells to begin to do this, which is to make these hairs. And so as we get older, you tend to get hairier ears and hairier nose. Unfortunately, I mean, that's a consequence of getting a bit older. You have to invest in sort of Noel Edmonds' pair of nose clippers, unfortunately. There's no sort of simple way to say it. But those hairs do actually have a use. It's not that they've suddenly sprung up. It's just that they're growing a bit more vigorously, and there are a few new ones. But their role is to filter out, as Dave can probably explain, the big chunks of dust and stuff that go up your nose.
It's basically just acting as a filter, so if you inhaled a load of dust, the big lumps would get stuck in your nose, and the smaller lumps actually get stuck in snot and mucus in your lungs and the back of your nose.
Quick go at the quiz?
Yes, please.
OK, here we go. The world's first waterproofs were made in the 1500s. Is that science fact or science fiction?
I would say a fact.
No, the early examples of waterproof clothing actually go back to 1600 BC, when the Mesoamericans would mix latex from the rubber tree with the sap of the morning glory vine and paper it onto waterproof fabrics.
Oh, OK.
The wheel was invented about 2,000 years ago. What do you think of that, James? Fact or fiction?
That's fiction.
Yeah, well done. The wheel first rolled onto the scene about 5,000 years ago in Mesopotamia, which is now in Iraq.
Well done. You got 1 out of 2.
Thank you.
Good to have you with us.
Sorting out the sparks from the quarks. The Naked Scientists.
And now to a man who's blasted his way into the record books, possibly this year, for setting off about 50,000 fireworks in about 3 seconds. That's Roy Lowry from Plymouth. Hello, Roy.
Hello.
Thank you for joining us on The Naked Scientist. So tell us a bit about your feet.
Well, it's very tempting to tell you that they're about size 9, but I know what you mean. Yeah, well, it took about a year to put together, but basically on the 16th of August, myself and about 60 people got together and spent the entire day putting rockets into frames, putting what's known as black match underneath them, which is basically gunpowder coated on the outside of string, running out a very long wire with a very satisfying, juicy-looking button on the end, and then pressing the button and watching the whole lot go skywards.
What was the point of doing this, though?
The point of doing this is simply because I have a thing about science and scientists. I don't know about you, but I have been to parties and people have said, what do you do then? I say, well, I'm at university, I'm a chemistry lecturer. And their eyes glaze over and you get something like, I wasn't very good at that at school. And they wander off and talk to an estate agent or an economist or something. And I hate to say this, but actually I have fun doing my job. It's the best job in the world. And I think it's about time we did something about it and said, actually, I can have fun. So I spent about a year doing quite a lot of calculations to try and make sure that this world record attempt would go off. And it did.
Has the Guinness Book of Records actually recognised your feat now?
It actually came back to me on Tuesday morning of this week, and I have a very impressive-looking certificate now with my name on it.
So it's right in time for November the 5th, which is encouraging.
Absolutely. It takes them a while to make sure that I've done it properly. We had to submit a heck of a lot of evidence, etc., but they got back to me in time, which is great.
Now, you must have faced some criticism for doing this, because some people would say, isn't this a waste of energy or waste of time? Did anyone criticise you?
I got a grand total of about half a dozen emails, and the major criticism was, please don't frighten our cats and dogs, which I fully understand. but we actually did it as part of the UK Firework Championships, which are held in Plymouth every year. So, in fact, what we were doing was adding an extra display onto an already noisy evening, and everybody knew that was coming. They had time to prepare their pets, etc. I did have one or two raising concerns on environmental grounds, but I had to point out that actually good old-fashioned firework technology is so old that, in fact, the molecules we're playing around with have been here for so long that they produce very little in the way of pollutants that can't be dealt with by natural systems.
So, in other words, were these fireworks going to be chucked away anyway?
Indeed. We were very generously donated a whole batch of, nearly 60,000 rockets because they'd, in fact, been outlawed for sales to the general public. They were, in fact, too small to be used by the general public. So we were actually acting as a very good disposal mechanism.
So if they hadn't been set off by you, what would have happened to them?
The alternative for any firework to just detonation is to actually soak them in water, which means that part of gunpowder is potassium nitrate, otherwise known as saltpeter. Now, you can soak that out of the gunpowder, at which point you've then got something which is no longer gunpowder. It's in fact just charcoal. Charcoal, of course, can you just chuck that away. It goes into the landfill and then becomes methane, which is an extraordinarily good greenhouse gas, so we really don't want that. Meanwhile,
so what you're doing is actually better off then for the environment?
Absolutely, yeah. If you've got these things and they need to be got rid of, this is a problem which turns up round the planet time and time again. We have something which has been created for a particular job, and then that job goes away, or maybe something's past its sell-by date. It's not any good just to say, right, we'll stick it in the bin. We need to think about where these things go.
I've got an email here from Teresa Kulkarni who says, when fireworks are released into the air, doesn't the things that they produce go into a fine dust? And is there anything to stop us actually breathing that in? Are there any health effects?
If you're close enough to breathe in a reasonable quantity of the smoke from fireworks, you're too close. It's that straightforward. Obviously, when November the 5th turns up and everybody's producing fireworks, that's, I can understand you get the occasional intake of dust, but really it's not dust actually, it's smoke, which is slightly different. The major things you're taking in are no different to if you've got a solid fuel fire at home and I know people go, oh, the smell of a real fire.
Hasn't Disneyland done some studies, though, to work out exactly how much is going up in terms of contaminants and heavy metals and that kind of thing?
I must admit, I'm a great fan of Disney for this. They actually set up a big firework display at the end of every evening when Disneyland closes for the night. And they actually, to make sure you get the full effect of the fireworks, they are actually exploded over a lake, so you get the reflection, and it's all oohs and ahs and wonderful. A set of analytical chemists went out and sampled both the water and the sediments in the lake to find out what effect 30 years' worth of nigh on 250 firework displays a year would actually make. And if there is a difference, it's so small that even the best instruments we have on the planet cannot detect it.
But perhaps, as Teresa was pointing out, the heavy metals and the contaminants have all gone home in the lungs of the visitors that day.
I can assure you that water is a much better scavenger for such things. No, I mean, to actually find nothing, even I was surprised, and I'm quite good at making sure I can back up my defence of something I love, which is fireworks.
Thank you very much, Roy, for joining us. That's Roy Lowry from the University of Plymouth, who has blasted his way into the record books by detonating more fireworks than anyone else has in about 3 seconds.
I love firework night, and I'm gutted that I'm going to be in a car on the M11 driving home tonight instead of going to watch the fireworks. I'm so sad about that. Anyway, you can relieve my trauma by phoning in with our teaser. The question tonight is, how many nerve cells are there in the average human brain? We've had Joan in Swapham who says 12 million. That's a bit on the low side. I can tell you the answer is more than that. Get phoning in now, 08459 25 2000.
Dave is in Ipswich and he's got a question. Hi, Dave.
Hello.
Thank you for joining us on The Naked Scientist.
Oh, that's great, yeah.
What do you want to talk about?
Insects. I've always wondered how they manage to fly. we know in the rain.
Well, that's a good question. And the thing is that relative to a raindrop, of course, an insect in some cases weighs a lot less. So it's literally like you being hit by an atom bomb if you were to be struck by a raindrop. So insects are actually quite scared of rain. They can bob around and try and dodge the drops. But a lot of things, if you take butterflies as an example, when the weather gets nasty, they go and hide under leaves because in the same way that Roger Hargreaves' Mr. Men used to have Mr. Small living under a daisy at the end of his garden, that's exactly what insects do. And they hang underneath petals and leaves because the leaves are shaped to make water run off because the plant doesn't want to make an ideal surface for fungus. So the leaves are set up like the perfect umbrella, like a golfing umbrella. And so if a plant is in a convenient place, then an insect will come and hang underneath to get out away from the rain, and they'll try to avoid flying because if they do get hit by water, A, it's cold, which cools the insect down, B, it makes its wings very heavy and stick together, which means that it could be curtains for the insect, and C, it doesn't want to get knocked out of the sky by a massive heavy raindrop.
I think some of the very, very small insects, like midges, do fly in the rain, but they're so small that the raindrop, the sort of wind, because there's a wind being pushed around the raindrop as it falls, and they're so small they'll actually just get pushed out of the way by this wind.
By this sort of vortex as it goes past. Do you want a quick go at the quiz, Dave?
Yes, okay.
Okay. The world's biggest city is New York. Do you think that's science fact or science fiction?
I think that's fiction.
You're quite right. It's not even close. New York has a population of 8 million, which is about the same as London's 7.5 million. However, both are tiny compared with Tokyo, officially the world's largest city at 35 million.
It's a lot of people. Doing well, Dave. 1 out of 2. In the UK, we quaff down 165 million cups of tea every day. Is that science fact or science fiction?
It sounds like fiction as well.
I'm afraid it's true. We do drink 165 million cups of tea. 96 million of them are made with tea bags, which apparently was invented by an American, a New Yorker, which is a bit peculiar.
Why, do you not think Americans are tea drinkers then, Dave?
Well, not as avid as in this country.
Dave, it was a great question, and you're currently in equal first place on our Fact or Fiction.
Oh, great.
Thank you for having us in your living room.
Thank you very much.
Take care. James is in Bar Hill. Hi, James.
Hi, good evening. How are you?
Very well, thank you. Thank you for joining us on The Naked Scientist. What do you want to talk about?
Yeah, it's the washing sachets, the washing machine sachets, the ones you drop in and then put your washing in and they dissolve sort of instantly. Yeah. I don't understand how they work because is the inside of these sachets lined with something that the outside isn't? Because I bought sort of a box of these a few weeks ago, and obviously one of them during the sort of travelling split. By the time I got home, the whole sort of box was just liquid. And I couldn't work out if sort of the liquid dissolves the sachet, how do the sachets not dissolve?
Yeah, I'm not entirely sure, but one of my guess would be that the liquid inside of it is quite a very strong liquid, which hasn't got much water in it, so it's not there's too much stuff dissolved in it already to dissolve the sachet. But if it leaks into the outside, water can get in from the air. Sometimes you leave salt out in the air, it'll go gloopy and wet.
Hydroscopic. So it attracts water and soaks up water.
Which will make the liquid have more water in it, so there's space for it to dissolve the sachets, and so all the others will then dissolve.
So it's a sort of positive feedback effect.
Sealed container.
Sorry, James?
Even though it was in a plastic sealed container.
Yeah, well, once... so there was air excluded from the container, or was it... Had you had a lid on it, but you could take the lid on and off?
Yeah, it had a sealed lid on it, this is what really foxed me, because it was a sealed lid, and when I took it out from the shopping, the whole sort of sealed container was green liquid. And I thought, well, it was okay when I bought it, and sort of 20 minutes later I've got a box of liquid, and I just couldn't work out how they don't dissolve within the sachet,
I think we're going to have to take that as homework then, James, because we've done our best with the idea that it soaks up water from the environment and that enables it to then dissolve the outside of the packaging, which is how these things work in the first place. But I think we'll have to have it as homework, and if anyone out there can help us, perhaps they'd like to drop me a line at chris@nakedscientist.com.
Yeah, because the air thing, I mean, I'd like to know, because it says on these packets that... your hands must be dry, so you can put one of these things on the side, and it will not dissolve. Because I tried this as well. I sort of put it on the side in the kitchen, and it just sat there.
We'll have to have it as homework. But do you want to go at our quiz?
Yeah, I'd love to, yeah.
Here we go, then. Tea made in a thin stainless steel teapot cools more quickly than tea brewed in a ceramic pot, big, thick ceramic pot. What do you think, fact or fiction?
I would have said... fiction.
Yes, according to a bit of kitchen science carried out by TV presenter Adam Hart Davis, when filled with an identical volume of hot water, a stainless steel teapot loses heat much less quickly than a thicker ceramic pot because it's shiny and is therefore a poor conductor of heat because it's a poor radiator. So there you go.
During the day, owing to the effects of gravity, the average person shrinks by over a centimetre. That's half an inch. What do you think, James?
I would have said that was true.
Yeah, well done. All that weight on your back squashes all of the lumps, the discs in your back, cartilage in your back, and makes you can shrink by about half an inch.
Thank you, James. You're in the lead with 2 out of 2. Great having you on the programme.
Thank you very much.
If you'd like to join in on The Naked Scientists, just call in on 08459 25 2000, text 07786 20 1960, or email chris@nakedscientist.com. Now, over the past year, the Kitchen Science team have been out to schools and homes across the country, but this week we're going to the place where most of the experiments were actually cooked up in the first place, and that's Dave's garage. So let's hear what Dave and Derek got up to earlier on this week.
In honour of Fireworks Night this year, Dave and I have actually come down to Dave's garage, and this is actually the first time I've been here, and it is actually pretty much as I'd expected. There are tools everywhere, boxes, there's a microwave, so all sorts of things to allow Dave to make up the science experiments that we do here. And on the lab bench, I suppose, that we've got here today, we've actually got some amazing stuff which is going to show us how fireworks actually work. And included in that is an angle grinder, a blowtorch, a load of powders, and I'm very excited about all these and what's going to happen with them. So why have we got all of these things kind of laid out, these possibly dangerous instruments? What are we going to be looking at?
The first thing we're going to think about is how things give off light in the first place. For example, if you pick up a screw with a pair of pliers here, and I turn on my blowtorch, if we put the screw in the blowtorch and heat it up, it will start to glow.
OK, so is this a similar sort of effect to what people might have seen when they thrust a poker into a hot fire for a while or something like that?
Basically, if you get anything hot, it will start to glow. So here, the screw is just starting to glow red at the end.
Yeah, the tip of the screw, it looks amazingly hot, actually. But yeah, it's got that kind of red, almost molten look to it.
And if we put in a little piece of wire here, which will heat up a lot quicker, as that gets hot, it goes right the way to orange and the wire melts, which is a bit of a mess, but yeah.
OK, yeah, so basically, yeah, that was just a thin piece of wire, and that actually kind of went beyond red to orange. Where would this end, of course?
If you got even hotter, it would get to white.
OK, so what's actually producing the colour?
Well, first of all, we've got to think about light. Light's made up of little lumps called photons, and the amount of energy they've got changes the colour. So something without too much energy is red, and something with lots and lots of energy is blue, and green somewhere in between. Now, the way you produce a photon is by taking some energy away from an electron. In a lump of iron or something, electrons have any energy you like. So you can think of them all sitting on a slope. If it's not very hot, they're all down the bottom of the slope and they're kind of jiggling around.
And that's where they've got low energy.
Yeah. And if it gets really hot, some will be a long way up the slope and have lots of energy. Now, if they give off a photon and lose some energy, they sort of fall down this slope. Because it's just a slope, they can fall down any amount they like, so you get lots and lots of different colours of light given off at once.
OK, so when it's red, of course, most of them are hanging around at the bottom, and I suppose you actually get quite a lot of red because they've only got a small distance to fall. That's all that's available to them.
Yes, and if you give it more energy, more colours will be available. So you start getting green light given off, and a mixture of green light and red light is going to give you an orange or yellow colour. If you get even hotter, they'll start giving some blue, so you get oranges, and if you get really, really hot, you'll get most of the light given off in the green, and you get white light.
Right then, so we've done that with a screw, but what can we actually look at now?
This is how you get sparks in fireworks. You basically make something very hot. Now, an easy way to show this is with my angle grinder over here.
OK, and this is the bit I'm really excited about. So what is the actual setup you've prepared here?
Well, basically, I've got a piece of iron in a vice, and I've got my angle grinder. I'm going to put on a face shield because this could get a bit lethal.
And I have my goggles on already. I'm very safe.
And I'm basically going to angle grind the steel.
All right, then. And we are obviously going to hear this loud and clear. I'm actually going to stand back a bit. But here goes Dave. We're going to angle grind some steel. An angle grinder, by the way, is kind of like a circular saw-style thing, but used for metal. All right, go for it, Dave. Whoa, OK, so we're now seeing sparks flying off kind of away from Dave, luckily. Sparks flying off at great speed from the point where the spinning saw was meeting the metal. So what were we seeing there? They were kind of orange in colour, I suppose.
Because steel is very, very tough, you can't really saw it very easily and you get very tired. So you use an angle grinder. The way it works is just by it wears away the metal very quickly because you've got this very, very fast-moving disc, and it tends to wear away little lumps of iron because they're getting worn away so quickly and the disc's moving so fast, they get really hot. Now, if you get iron hot, it will burn, and so they stay hot quite a long way, and that's what you see as a spark.
OK, so we were seeing flying tiny lumps of burning metal there, burning steel, and that's cool. OK, so what are we going to look at now? We've actually got some other colours to produce here, I suppose.
Well, yeah, a couple of hundred years ago, the only colours they could make were kind of whites and yellows and reds, because this is the only technology they could use, just making things hot. Now, after that, chemists found some much better ways of making really funky colours.
Now, in front of us, we're back with the blowtorch again, and we've got a bunch of powders, basically, white powders, which Dave has actually already made into quite concentrated solutions. And he's also got kind of a little prong of metal, which he's going to use in some way. What are you going to do?
Well, I'm going to put a little bit of these solutions on the end of the metal and put it in the blowtorch and see what effect it has.
OK, so what's the first chemical we've got?
The first chemical we've got is one you've probably come across at home. It's sodium chloride, or just table salt.
OK, right, so here we go, and I'm going to commentate while he sticks it in the solution and then into the flame, and we have a rather pleasant, if a little uninspiring, kind of orange colour coming off that. So it's the kind of flame colour that you'd get when you burn a match, I suppose, that sort of thing. So
that was sodium, that produces an orange light.
What have we got next?
One you might remember from school is copper sulphate.
OK, copper sulphate. OK, and this goes a very nice green, actually. Burns out really, really quickly.
Basically, what's happening here, when you put the solution into the flame, it boils, and that throws out lots of metal atoms. Now, if you just got an atom on its own, instead of the electrons being able to go anywhere up the slope, it's a bit like the electrons only being allowed to survive on steps. So instead of on a slope, they're on steps. Now, this means that they can only jump down certain distances. And if those distances happen to coincide with a nice colour, like green, for example, then you'll get lots of green light given off.
OK, so basically, instead of having a large variety of possible drops that the electrons could have, thus giving out lots of different wavelengths of light, you've actually got quite precise ones. OK, and so how does this all relate to fireworks?
Well, this is how you make the nicely coloured fireworks. You put in some metal salts, some copper or some lithium, or lots of other metals and make different colours. And you blow them up in your explosive and you get them really hot. And because the electrons can only jump certain distances, you get really nice colours.
All right, so there you go. So thanks very much for that, Dave. And that's how fireworks do work. And we're going to head back to the studio. But because we're actually having so much fun with all these power tools in Dave's garage, we're going to do a bit of angle grinding just to see you off. So let's go for it. And that is all from Dave and myself in Dave's garage. So it's back to the studio. Thank you.
Thank you for that, guys. And if you want to have a go at next week's Kitchen Science, you won't need any special equipment or any angle grinders, but you will need to be listening very carefully because one of our guests is setting up an audio lineup. It's like a lineup in a criminal investigation, but with voices. So if you want to find out what that's all about, tune in next week.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Got an email here from Rupert, who's actually says... Dear Dr. Chris, thank you for the show. I think it's the best science podcast out there. Thank you very much for that, Rupert. He says, I'm an exploration geologist and normally listen to the show out in Kyrgyzstan whilst looking for gold. After listening to this week's show, he means last week's show, I thought I should point out that the melting associated with subduction zones is no longer thought to be as a result of friction. Now, if you remember, someone, I think it was Andy actually, phoned in to talk about when a part of the ocean floor reaches out to where it meets a continental crust and one thing gets sort of subsumed or sunk below the other. He says the melting is due to the addition of water to the mantle overlying the subducted part of the plate. The water lowers the melting point of the mantle rocks, so the rocks melt and start to rise to the surface. So it's not friction, as we sort of discussed on the programme. Dave?
We've got a question here from Jenny on text. It is, why after eating asparagus does your urine smell so strong? Maybe one for you, Chris.
Have you seen this? Well, not seen it, but have you smelt it?
I have, yeah.
It definitely is true. And it seems to be that there's some chemical in asparagus which is absorbed from your gastrointestinal system, your gut. It passes out through the wall of the gut into the bloodstream, and it's obviously soluble in water because it then passes out of the bloodstream and into urine. So the kidney can obviously either secrete this stuff or it gets filtered out by the kidney and it gets concentrated in urine. And it's obviously some kind of volatile chemical because when you do a wee after you've eaten some asparagus, it happens as little as, say, half an hour afterwards. You begin to develop very smelly wee. No one actually knows what that chemical is, and there's some debate over whether everyone can actually smell it, because some people have said that they are never able to smell the smell after they've eaten the asparagus, but they are.
Maybe it's a genetic thing. We've had a really quick question here, also on the text line, is do white blood cells multiply by mitosis? The answer is yes, that's the normal process of cell division, and they're made from stem cells in your immune system, usually hanging out in places like your bone marrow, your thymus, all those kind of glands. So,
very quick one for you, Dave. This is from Cindy Gresham, who's actually listening in Houston, Texas. She says, I love to listen to your podcast while driving the kids around in the car. Whenever the subject of Knight Rider comes up in conversation, that's David Hasselhoff and that lot, you'd be amazed. My husband has the following question. Is it really possible to drive a car onto the back of a moving trailer? If so, how would that work? What kind of acceleration and braking would have to be done to achieve it?
Well, yes, I see no reason why it wouldn't do, as long as your trailer's set up right. Basically, you're just going to be going a few miles an hour faster than the trailer, enough, and when you hit the trailer, you've got to have your foot on the clutch, because otherwise the wheels will be going really fast, and you hit the trailer, and they should be going much faster than they are actually going. And so as long as you've got your foot on the clutch, you'll just be on the trailer going at 10 miles an hour rather than on the road going at 90.
And of course, the Hoff can do anything, so that's why he can do it.
Let's just go to Susan, who's in Great Yarmouth. Hello, Susan.
Hello.
Welcome to The Naked Scientist. What do you want to talk about?
Thank you. My daughter has an unusual disease, and I hope I'm saying this right. It's called Unverricht-Lundborg disease, which she's inherited from me and my partner. It was in gene 21, and apparently you get a good gene from the mother and a bad gene, and the same from the father, and she got the bad from both. And what I really want to know is, why did it only affect her when she was 8 years old? If it was a genetic thing, why didn't she have it when she was born?
It's an excellent question, Susan, because you're quite right. You've inherited these genes. They're switched on from the minute you're conceived as an egg, pretty much, until the time at which the disease is picked up. So why don't you get it immediately? Because the genes are always switched on. The answer is that it takes a little while for the bad thing that those genes do or does to accumulate. So if you imagine, say you have a gene for heart disease, and this causes blood vessels to block up, well, they're always going to be making the blood vessel blocking up thing, whatever that is, but because the blood vessel has a certain diameter to it, it takes a while before the fatty deposit blocks the blood vessel all the way. So in the brain, for example, you have a nerve cell which is making the content or the product of this gene, and it's building up inside the cell, but it's not necessarily there in enough of a concentration to start with to actually cause a problem. There's another disease which is called Huntington's disease, which is inherited in a slightly different pattern to the one which you're describing. But in that disease, in the brain, you have that gene switched on from the minute you're born, but you don't actually get the symptoms until the age of, say, 45 onwards. And the reason is that in the cells that are affected, they're building up this waste product that slowly accumulates, and it's a bit like having a dustbin. Eventually the dustbin will overflow, and when the bin starts to overflow, it starts to affect the cell. So eventually the cell's ability to cope with this waste material is expended, and unfortunately you start to have problems. So that's one example of how you can have a gene, you inherit a condition, and it doesn't actually manifest itself for a number of years. But that's probably the simplest that I can sort of explain it in the time we have available.
Okay.
Do you want to have a quick go at the quiz, Susan?
Yes, why not?
The mammal with the largest brain in the world is the African elephant. Is that fact or fiction?
Fiction.
Yes, you're absolutely right. The sperm whale has the record for the largest mammalian brain. It's 7.8 kilos, compared with 1.5 kilos for the average human brain. So, unfortunately, whales aren't that clever, though, even though they have a big brain.
A clock at the top of a mountain, Susan, runs more quickly than a clock at sea level. Science fact or science fiction?
Fiction.
Unfortunately, it's true, because gravity will actually distort time, space-time, and mean that when you're in the bottom of near something very heavy, time will actually go slightly slower. It's
very confusing, very weird, but it's very true too. Thank you for joining us, Susan.
Thank you.
Andy is on the A120. Hello, Andy.
Hello, mate.
Now, your question, appropriately enough, is about gravity, but we're going to have to be very, very quick with it. So what is it?
Right, is gravity around this planet of ours constant? If you think of a spinning ball with a penny placed at the very north pole of it, the ball can spin as fast as it likes, but the penny won't shoot off. The nearer you move that penny towards its equator, there'll be a gyroscopic force there throwing it outwards.
Gravity is nothing to do with spinning. So the actual gravity will be constant, approximately constant all the way around. It'll be a bit larger at the North and South Pole, because the North and South Pole, the Earth is slightly flattened. How much weight you feel will vary slightly different due to the centrifugal force, because you are being thrown out again, because the centrifugal force is counteracting gravity, but the actual gravity would be constant if the Earth was a sphere.
10 kilo weight at the North Pole won't weigh 10 kilos when you take it to the equator.
It would probably weigh slightly less than that.
All right.
Andy, we'll have to leave it because we've run out of time.
No worries, mate.
Thanks for having us in your car. All right, thanks for joining us.
Cheers.
You've been listening to The Naked Scientist with Dr. Chris, Dr. Kat and Dr. Dave. Thank you to everyone in Radio Europe for joining us. Our winners this evening, the teaser, the winner is Steve, who's in Essex, and our quiz winner, James in Bar Hill. What was the answer, though, Kat?
The answer is that we have 1,000 billion nerve cells in our brain. That's about 10 to the 12, or a million. That's quite a lot, though I think some of us have slightly more, some of us have slightly less.
Speak for yourself. Apparently each of those nerve cells makes about 1,000 connections, which means you have 1,000 million different connections between nerve cells in your brain, which is quite a lot, really. Next week, we're going to be getting into the spirit of the Cambridge Music Festival by looking at the relationship between maths and music. Why a piano is always out of tune, for example, and has symmetry influenced jazz? Does music have a geometry to it? And what's the relationship between our windpipe and a clarinet? So if you have any questions on those subjects, or you just want to say hi, we'd love to hear from you. Please do drop us a line to chris@nakedscientist.com. And if talking about science is your bag, then you might like our forum. If you go to nakedscientist.com/forum, there's a thriving science discussion forum where you can ask and answer questions from people all over the world. In the meantime, if you'd like to hear a bit more about science, then you can also have a listen to the Nature podcast, and there are more details about that at nature.com. Thank you to our wonderful production team, Anna Lacey and Petro Minch, who helped to put this show together. Until next time, goodbye.